This is the Real Tom Rose, and we're asked to categorize a couple of hypothetical expressions, knowing that A is even and B is odd. Now, let's start one at a time. Take the first one. It says A times B. I'm going to actually rewrite this as even times odd. Now, one thing you can do to drastically shortcut this is memorize a table of the relationship between evens and odds. So you could memorize, it's not a very big table, you could memorize all of the, what if I add even and odd and odd, odd and even? What if I subtract even from odd from even, odd from odd? What if I multiply even, odd, even, odd? And division actually doesn't have a consistent result, but you can memorize the addition, subtraction, multiplication table for evens and odds. And that would allow you to see that, okay, if we take an even times an odd, I just know that that's an even. It'll always be even, and you can read that right off that table. Now, if you don't have that table memorized, or for whatever reason you don't like memorizing tables or can't memorize tables, another way to do that is you can plug in the numbers 2 and 3 for this. So if you plug in 2 for even and 3 for odd, you'll get 6. 6 is an even number, so that you can use that to regenerate this table. So that's statement 1. 1 will always be even. It asks us which of the following must be an even integer. And 1, in fact, must be an even integer. So I'm going to put a check mark there. Now, statement 2 says 2 times A, which is even, plus B, which is odd. So now an even plus an odd will always be odd. And you can check that again with 2 and 3 if you like. It will give you the answer 5. So now this becomes, 2 is of course an even number, multiplied by something which will always be odd. So an even times an odd, again, will always be even. So statement 2 is always even. Statement 3 gives us A times B, which is an even times an odd, minus 2, which is an even, divided by 2. I'm just going to leave the 2 in the denominator. So first of all, one way you can shortcut this is you could say, well, I know that for division, we don't get a consistent result. So at this point, I already know we can just eliminate this. But if you don't have that memorized, we can go through and kind of prove it. Let's say you have an even times an odd. An even times an odd will always be even, which leaves us with even minus even over 2. And even minus an even will always give you an even. You can check that with 2 and 2, for example, or 4 and 2. So that leaves us with even divided by 2. Now, an even number divided by 2 will always give you an integer, but it's not always guaranteed to give you an even integer. So for example, you can check out, let's check out 4 and 6. 4 divided by 2 is 2. 6 divided by 2 is 3. So we get an integer in any case, but sometimes it's even and sometimes it's odd. So this one does not work. So the answer will be 1 and 2, which is the third answer choice.